You're listening to the N2K Space Network.
And now, a word from our sponsor, SpyCloud, the cybercrime analytics leader. SpyCloud disrupts cybercrime by telling you what criminals know about your business and your customers, so you can take action to prevent ransomware, session hijacking, account takeover, and online fraud. SpyCloud constantly recaptures and analyzes new data from the criminal underground, including credentials, session cookies, and PII siphoned from malware-infected devices. With knowledge of the specific exposed data criminals have in hand from InfoStealer malware on managed and unmanaged devices, security teams can respond with a more efficient and effective process called post-infection remediation that fits seamlessly into existing incident response frameworks. Get SpyCloud's post-infection remediation guide outlining the 7 steps for preventing a malware infection from becoming a full-blown ransomware incident. Visit spycloud.com/cyberwire. That's spycloud.com/cyberwire. And we thank SpyCloud for sponsoring our show.
The Cold War space race was a struggle between the Soviet Union and the United States. The pursuit for both was the domination of spaceflight technologies. The technological advances were seen as necessary for national security and political superiority. It was a remarkable time in history, with many far-reaching achievements in science, space exploration, and technology. And right now, it looks like history is about to repeat itself.
T-minus 20 seconds to LOS speed rest. Go for deploy.
Today is August the 14th, 2023. I'm Alice Carruth, and this is T-minus. Russia receives its first data from Luna 25. India holds parachute testing for human spaceflight programs. China launches the first geosynchronous orbit synthetic aperture radar satellite. And our guest today is Annika Wollermann, Chief Commercial Officer at German-based spacecraft manufacturer Polaris. On to today's Intel briefing. It's the Race for the Moon 2.0 edition. On Friday, we reported that Russia launched its Luna 25 spacecraft that put the country in a head-to-head race with India to be the first nation to soft land on the lunar South Pole. And it's all the industry has continued to talk about. The Russian Space Agency says that they're already processing data from Luna 25. Roscosmos switched on the scientific equipment on the vehicle and says that the first measurement data on the flight to the moon has been obtained. Luna 25 is expected to reach the moon on August the 21st. At about the same time, the Indian Chandrayaan-3 mission is expected to land at the same coveted location, the moon's south pole, where ice is the new gold. Russia has also announced that it plans to launch further lunar missions and then explore the possibility of a joint Russian-China crewed mission and even a lunar base. This announcement has left analysts drawing parallels to the Cold War era space race. Back then, the Soviets were the first to conduct a soft landing on the moon, but it was the Americans that were the first to land humans on the surface. It all sounds very familiar, as NASA is focusing on the Artemis missions and returning astronauts to the moon next year. Meanwhile, the Russian Space Agency has announced that the airport of the Vostochny Cosmodrome has received the first airplane. The airport is still under construction, but the test flight was held to check the technical readiness of its runway. The aircraft was operated by the crew of the Gagarin Cosmonaut Training Center, headed by the commander of the Joint Aviation Detachment. And back to India's human spaceflight ambitions, the Indian Space Research Organisation, known as ISRO, successfully conducted a series of drogue parachute deployment tests which will help their astronauts land safely from space. The tests are for the Gangneung mission, which will take 3 crew members into a 400-kilometre orbit for a 3-day mission and bring them back to Earth by landing in the Indian Sea. That mission is expected to be held next year. And India is not just reaching for the moon. The country's first solar mission is expected in the coming weeks. The Aditya L1 spacecraft has reached the launch facility in Andhra Pradesh. Aditya 1 will observe the sun from 1.5 million kilometres above the Earth's surface. ISRO hopes to launch the vehicle by the end of this month. China launched 5 new satellites to orbit on Monday. The vehicles will be part of the country's very high-frequency data exchange system satellite constellation. Chinese media says that the satellites will be used for an integrated transportation security system of land, sea, air and space, meaning that it will offer a basic guarantee for maritime intelligence shipping communications, ocean situational awareness, and intelligent ocean exploration. The China Aerospace Science and Technology Corp also announced that it launched the first geosynchronous orbit synthetic aperture radar satellite for disaster monitoring over the weekend. The LSAR-401 satellite aims to improve the accuracy and efficiency of disaster event information and enhance the comprehensive prevention and control capabilities of natural disasters. In the face of China's fast-growing space capabilities, the US is ramping up space collaboration with key Asian allies Japan and South Korea. The upcoming trilateral summit at Camp David on August the 18th will further address space cooperation. While historic tensions have previously hindered Japan-South Korea collaboration, recent steps, such as data-sharing accords, joint monitoring initiatives and cross-national private sector investments, indicate increasing regional interoperability and a warming relationship. With Japan's established space assets and South Korea boosting its space budget, the US sees a strategic opportunity to enhance space defense and surveillance in the Western Pacific region. Space News is reporting that during a recent South American military exercise, US Space Force and allies utilized commercial satellite imagery to locate illegal fishing boats. This demonstrated the utility of unclassified commercial satellite data for maritime security and military applications, enhancing data sharing among international partners. Despite the increasing availability of such imagery, the DoD has been slow to integrate these commercial capabilities into operations. Space Systems Command has initiated efforts like the SRT program to bridge this gap, emphasizing the timeliness of data and expanding collaborations with commercial partners. SRT, or Surveillance, Reconnaissance and Tracking, is Space System Command's program to procure data from commercial satellites in near real time for mission-critical and tactical operations. Once overlooked regarding its environmental impact, the space industry is facing scrutiny similar to the global aviation industry for its carbon emissions. A recent study highlights significant climate effects and potential health risks from rocket launches, particularly from standard rocket fuel RP-1. However, the industry is undergoing a green transformation. Companies are exploring propane, notably biopropane, as a cleaner fuel alternative, potentially reducing CO2 emissions by 96%. Additionally, initiatives like Scotland's Sutherland Spaceport, which aspires to be the first carbon-neutral spaceport, signify the industry's evolving sustainable approach. Certainly more work to be done, but the focus is there. And a few forward-looking statements to finish off today's Intel Brief. That's a business law joke for those who missed it. Last week saw a host of hugely positive second quarter earnings reports from the likes of Black Sky, Redwire, Rocket Lab, Spire Global, and Viasat. Will that sunny outlook hold for the quarterly reports released this week? We'll be hearing from Astra, Intuitive Machines, Momentus, Cyberspace, and Terran Orbital. Stay tuned for our reporting on their results as well. That concludes our briefing for today. But as always, you can find links to all the stories we've covered for further reading in our show notes. And we've also included some opinion pieces on how the Space Force is preparing its ground systems for dynamic ops, and one on India embracing America's vision for outer space. You can find them all at space.n2k.com. Hey T-Minus crew, every Monday we produce a written intelligence roundup. It's called Signals and Space. If you happen to miss any T-Minus episodes, this strategic intelligence product will get you up to speed in the fastest way possible. It's all signal, no noise. You can sign up for Signals in Space in our show notes or at space.n2k.com.
This episode is brought to you by Palo Alto Networks, the leader in cybersecurity. As AI-driven attacks increase, organizations can't afford to have network security that's stuck in the past. Discover how Palo Alto Networks can help you predict what's coming and proactively secure against it with a zero-trust, AI-powered network security platform built to secure whatever, whenever, wherever. To learn more, visit paloaltonetworks.com/network security platform.
Our guest today is Annika Wollermann, Chief Commercial Officer at Polaris. Polaris is developing a new style of launch vehicle. I started off asking Annika how the company started and what they're aiming to achieve.
Polaris, we're a German startup based in Bremen, so in northern Germany, and we are a spin-off of the renowned German Aerospace Center, the DLR. And to put it in one sentence, our vision is an airline-like semi-single stage to orbit spaceplane operation, which is completely reusable and capable of a variety of especially bidirectional space transportation missions. And we're aware that this is an ambitious vision, and probably a couple of those terms I've just mentioned are able to trigger extensive discussions by themselves. For example, the semi-space to orbit aspect, which with today's technologies, we agree that a true single stage to orbit is not possible. But with future technological advancement, and especially with the help of a horizontal launch support system, for which we're actually in the process of patenting one, we are definitely keen to view this vision and to show that also German deep tech startups can dream big.
I like it. I love your ambitious approach. Now, you're new to Polaris. Can you tell me a little bit about what attracted you to this company and what it is that you're doing for them?
Yeah. So maybe, therefore, it's helpful to know a bit better where Polaris is coming from. So as I said, that it emerged from the DLR because our founder, Alexander Corp, worked there for several years as a system engineer. I think his position was called like Advanced Space Launcher and Hypersonic Vehicle. So really cool sounding position. And Polaris nowadays really capitalizes on like 3 decades of the space transportation research of this very institute. But this scientific concept reached a stage where there was enough research done and it just needed to be realized and also commercialized. That's why I entered the game. But back then, that was the point when Alexander quit his job at the DLR, actually moved back to his parents' farm and started developing the very first demonstrator in their shed. So it's a real life startup romance. And yeah, more than 4 years and 22 test flights later, here we are. And I'm really looking to drive this concept down the commercial runway.
So Polaris has taken a kind of scaled approach to your demonstrations over the last few years. Can you talk us through how it is you're working on coming from a small scale vehicle up to what it is you're hoping to achieve eventually?
So we have a successful history of our demonstrator projects, and we are right now developing, building, assembling our 4th demonstrator, a 1:6 scaled version of our space plane, which will demonstrate or pilot test our newly developed linear aerospace rocket engine, but which we maybe can catch up at a later stage of this discussion. It's a very interesting chapter in itself. And yes, so we have a successful history, a trajectory of those demonstrators. We just started with what we have and I mean, this is what you have to do in space, right? You just have to start, you have to build, you have to get out and test there. I mean, otherwise you cannot improve, especially when it comes to technologies like the Aerospace engine. There has never been a linear Aerospace engine in flight being tested before. So we're at a point where we just go out there, test, have success. I mean, until now, we're more on the success side. But of course, there will be some fails upon our roadmap, but that's space. And we're just keen enough to go out and try, test, go back, optimize our concept, and then go out there, do another flight campaign, refurbish the demonstrator, build a new one. And that's how we technologically de-risk our roadmap. But also, and that's where my position is coming in, we are also financially de-risking our roadmap because our demonstrator are fully functioning commercial drones, high velocity drones that are able to generate and not only able, they actually already generate revenue, which is financially de-risking our roadmap to the point that we are almost mirroring 101 the amount of money that we raised through investments with already secured revenue.
Obviously, you're aiming to get Polaris to be commercially viable. What is your main payload that you're thinking is going to really bring that profit into Polaris?
At Polaris, we like to say or to claim that our spaceplane applications start where conventional rocket applications reach their limits. And yes, that's a bold statement, but I mean, startups need bold statements, don't they? And we really like to emphasize that and also we call our spaceplane a multi-purpose platform for space transportation because we want to emphasize that we're more than just a launcher. Our spaceplane is capable of both suborbital and orbital missions. And we also like to claim that we're enabling true launch as a service solution. That's our USP.
So we talked about point-to-point a little bit earlier and how that is such a big buzz right now. Is Polaris looking to do point-to-point transportation from Europe to the US and around the world?
That is one of the use cases that we foresee in the longer term, and it's definitely an interesting market. But we, as I just said, we're more than that, and our main focus is really on the bilateral or bidirectional space transportation, so from the Earth to the low Earth orbit, and also, most importantly, back. And there we have a couple of advantages compared to conventional vertical rocket launching systems.
Can you talk me through those advantages compared to what other companies are offering on the market right now?
Yes, of course. So there are several aspects, but maybe let me narrow it down to the three fundamental characteristics. So first of all, we take off and land like ordinary airplanes from runways of commercial airports all over the world. Of course, some airports are more suitable than others for our operations, but we're way more flexible than those vertical launch systems because we do not underlie the extensive launching restrictions when it comes to population density, geographical positioning, and so on. And as we take off and land under turbine thrust, we can operate like conventional aircraft. And also, we do not require the costly and complex launch infrastructure in the first place. And this is actually key because this would enable countries all over the world to have sovereign access to space. Because in fact, around today, 40% of the world's countries will never have independent access to space with the conventional rocket launching system. Then secondly, there's this buzzword of responsive launch out there, where especially in a military context, it's all about the capability to react as fast as possible in the context of space. And one very important component of that is the rapid launch. And I think I do not have to say more than that we only need like 24 hours until we're ready to take off. And we even have the ability to do stopovers at other airports to ultimately take off from the most suited airport. And that drastically reduces the time to final orbit. This flexibility is truly game-changing in our view, and especially in a military context, in, let's say, special situation, a very big value. And then thirdly, we pursue a reusability of up to 200 missions. And before the aerospace engineers of your audience start arguing that this reusability rate does not hold, it's not for every subsystem, e.g. the rocket engines will be reused probably around only 20 times, but overall the system will be refurbished and reused up to 200 missions. And this leads to our two main advantages. On the one hand, we will have the lowest carbon footprint from a holistic cradle to grave perspective, because the emissions of the manufacturing are split upon the 200 missions and not only one missions or partially one missions if you refurbish parts of the launch system. Some people might think it's nice to have and good to promote aspects of our operations. But actually, big global satellite operators like Airbus or companies that rely on the downstream services of satellite like AT&T have officially committed to the 1.5 pathway of the Science-Based Target Initiative that you may know, the SBTI, or maybe Microsoft, which has announced they operate carbon negative until 2030. And in order to do so for those companies, the carbon footprint of the satellite launches need to be minimized as well, because those account for their Scope 3 emissions. And these emissions are the emissions that a company has, that the company's value chain is indirectly responsive for. So that would be the case when operating satellites or using satellite services.
I want to switch gears a little bit for my last question for you. We don't really hear much about the aerospace industry in Germany. Can you talk a little bit about what kind of support you're getting from the German government and from the industry as a whole over there? What do you see the future being for them?
So especially in Germany, we have a really big momentum when it comes to space transportation. Mainly driven or very prominent are our 3 micro-launching companies that some of you might heard of. So ISA Aerospace, the Rocket Factory Augsburg, and High Impulse. So these have been around for a couple of years now. So there's a big awareness and also a big momentum in Germany that's really looking to support those new space startups. I mean, we have also other new space startups that are just now going through the roof, like Live.io, Mynaric or Aurora Tech. So we have a really thriving new space startup culture. And I think what's also really nice that we see ourselves more as European, or how do you say, like, we have the advantages of being also a European startup. And of course, with the ESA, with the European Union, with the European Commission, do not solely rely on our national funds and supporters, but really can benefit from a whole continent, because there in space, Europe really unites. And that's really nice to see.
We'll be right back.
Now, a word from our sponsor, the Johns Hopkins University Information Security Institute, currently seeking qualified applicants for its innovative Master of Science in Security Informatics degree program. Study alongside world-class interdisciplinary experts and gain unparalleled educational, research, and professional experience in information security and assurance. Interested U.S. citizens should consider the National Science Foundation's CyberCorps Scholarship for Service program, which covers tuition and a $6,000 annual professional development allowance, as well as providing a $37,000 additional annual stipend. Apply for the scholarship and the fall semester by March 1st. Learn more at cs.jhu.edu/MSSI.
Welcome back. The James Webb Telescope continues to deliver on its promise to reach into the depths of the universe and deliver us with information that we can only imagine in our dreams. The most recent image is of a distant star called Earendel. It's the most distant star that the space-based telescope has captured to date. Earendel is 28 billion light-years away from the Earth. It's a super hot and super bright B-type star, surpassing the heat of the Sun. Scientists have concluded that Earendel is incredibly minuscule, approximately 4,000 times tinier than our usual observable threshold. This designation positions it as the most remote star ever detected, having emerged just 1 billion years following the Big Bang. The James Webb Telescope used the gravitational lensing technique to capture this distant ball of gas. The image has been hailed as a breakthrough and offers profound insights into the early universe and its initial stars. Just incredible. That's it for T- for August the 14th, 2023. For additional resources from today's report, check out our show notes at space.n2k.com. We'd love to know what you think of this podcast. You can email us at space.n2k.com or submit the survey in the show notes. Your feedback ensures we deliver the information that keeps you a step ahead of the rapidly changing space industry. We're privileged that N2K and podcasts like T- are part of the daily routine of many of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. N2K Strategic Workforce Intelligence optimizes the value of your biggest investment, your people. We make you smarter about your team while making your team smarter. Learn more at n2k.com. This episode was mixed by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Brandon Karff, our chief intelligence officer is Eric Tillman, and I'm Alice Carruth. Thanks for listening.